All right, just wanted to show you a couple graphs here with our functions. I've given you function x squared and then the inverse square root of x. Again, that would be because I started with y equals x squared, switched my x's and y's, and I'm going to get y alone, so I have to square root that. The square root of x is my inverse function. Now do keep in mind that this graph actually kind of shows it that we technically wouldn't have an inverse for x squared. It fails a horizontal line test. It crosses. It doesn't have unique values for each x value. So we would say technically it doesn't have an inverse. We're going to ignore this part. We're going to limit the domain. So if you ever get asked a question about could you limit the domain to give a function an inverse, yes, we would limit the domain from 0 to infinity for this one. That would make sure I don't ever repeat any y values. Each x maps to a unique y value. Now when you graph these, we talked about it a little bit, there actually is a correlation between functions and their inverses. They should be reflected over the line y equals x, kind of like a mirror there. If we look at the next slide, we have the function and its inverse. Again, to give you an extra practice of showing how to find that, here's my original. I switch my x's and y y's. Can never practice enough inverse finding. So let's subtract 2 from both sides. We have x minus 2 equals 5. Y. Divide by 5 on both sides and divide the whole thing by 5. So I have x minus 2 all over 5 equals y, which again is y. This is my inverse. And again, if you draw that line y equals x, the cool graph that does show like it's reflecting over that line. A couple more examples here. If I give you 4x minus 5, I have y equals 4x minus 5. I switched my x's and my y's. I'm going to add 5 to both sides. X plus 5 equals 4y. So divide by 4, all of it by 4, so x plus 5 all over 4 gives me my y value, which is my inverse. Again, neato burrito, there is that line that cuts down the center there. Let's see if I have one more for you. Oh, yes. Ignore my notes to myself here. Okay, so we're going to try to find the inverse of this function. That's the same thing. We have y equals 5 over x. If I switch my x's and my y's, I'm going to multiply by y on both sides to get the 5 alone. So I have y times x equals 5. I want to get the y alone, so I'm going to divide by x. Well, look there, we have y equals 5 over x. That's what we started with. So, fun side note, one of these functions, it is a chance that the original one matches, so this function is its own inverse. And if I draw that line down the center here, y equals x, it does reflect over that. That would be a folding point. So, just kind of a unique example that maybe you haven't seen before.